Hello, my friends. I'm Clover, and today we are solving a puzzle called Not Slow Thermo by Philip Newman. This was originally posted in Gas on June 26th, 2024. And I believe the reason it is called Not Slow Thermo is because Philip was describing himself as being particularly slow getting moving in the morning when he was about to post this, and somebody posted and asked, so surely today's puzzle is going to be a slow thermo Sudoku. But no, this is not in fact a slow thermo Sudoku. So what's going on here? So we have killer and arrow. So first of all, we have standard Sudoku rules. So we're placing the digits 1 through 9, once each in each column, each row, and each outlined 3 by 3 region. Then we also have these cages in the grid, these kind of dashed outlined cages, and what those mean is that the sum of the digits that are within a cage has to equal the little clue value that's given in the top left corner of the cage. And also there is typically a rule in Killer that digits can't repeat in a cage. Here, as it often is in Gas, that rule is not going to be relevant to our solve just because every cage is contained within a single row or single column, so digits can't repeat there anyways. And then finally we have these arrows. Arrows indicate that the digit in the circle has to equal the sum of the digits along the attached arrow line. We do have some circles that have multiple arrows attached to them. I've seen this be a source of confusion before among folks who haven't seen a lot of arrow Sudoku, so I'll just explicitly call out what's going on here, which is that each arrow independently has to sum to whatever value is here. So you don't total up all 4 of these. Instead, to do this bulb, you take the sum of these, and that's got to equal that number, and then also separately, the sum of these has to equal that number. So like if this was a 4, this would have to be a 1 and 3, and then that would also have to be a 1 and 3. So that said, let's have a look. So these cage totals are very familiar to me as somebody who does a lot of killer Sudoku. These are, I believe they're called pyramidal numbers or triangular numbers. Tell me in the comments if I've gotten that completely wrong, or confirm if I'm completely right. So the significance of them is that, for instance, a 3 in 2 cells has to be the lowest possible 2 digits. Same with 6 and 3 cells, that has to be 1, 2, 3. 10 and 4 cells is always 1, 2, 3, 4. 15 and 5 cells is always 1, 2, 3, 4, 5. 21 is 1, 2, 3, 4, 5, 6. And finally, 28 is 1, 2, 3, 4, 5, 6, 7. And really, I'm just pencil marking this to be a bit silly at this point. Realistically, I would not be pencil marking if I was solving this on the fly. 7 potential digits in 7 cells, but I just wanted to kind of drive the point home of what exactly is going on here with the structure of this puzzle. So now let's reduce this a bit using what we just placed. So this 1 and 2 makes this a 3, and also you can see that the arrow makes this a 3, so that eliminates 3 here. So now we have 1, 2, 3 here, which makes that a 4, and I can eliminate 4 here. 1, 2, 3, 4 here makes that a 5, and I eliminate 5 here. 1, 2, 3, 4, 5 here makes that a 6, and I'm going to eliminate 6 there. 1, 2, 3, 4, 5, 6 in the row makes this a 7, and I'm going to eliminate 7 there. And now I get a couple of additional kind of eliminations from that. So 1, 2, 3 here will make that a 4, and I'll eliminate 1, 2, 3, and 4 from those cells. And I can eliminate 1, 2, 3, and 4 from this cell and make that a 5. And that is actually going to end up being fairly important because now I know I have to make a total of 5, and on top of that I know I can't use a 4. So that's got to be a 2 plus 3, making this a 1. This also has to be a 2 plus 3. That's the only way I'm going to make a sum of 5 in those cells. And now this is a 1, and 4 is 1 plus 3, so that's my 3, that is my 2, and I can do some quick eliminations here. Now, what else can I do here? That's got to be 5 or 6, so 7 is either 5 plus 2 or 6 plus 1. So this cell is going to be either 1 or 2. And because we've just placed a 1 here, that'll be a 2. And so I know that's a 2, 5 pair. So this will be either 1 and 6 or 3 and 4. Could be either at this point. We will get there. Now, 6, a sum of 6 and 2 cells that see each other that doesn't include a 5 has to be 2 and 4, and there's only one way around that could go here. And that's actually enough to tell us the locations of all of the other digits in this cage. This 2 makes that a 1 and makes that a 2, and I don't think we can squeeze much else out of this. This can't be a 3, and this can't be a 4. Okay, oh, and we have a 2 in this region, so that's a 1, that's a 2, this can't be a 1. Interestingly, and I'm not sure that we're going to necessarily need this, but I just want to show it to you anyways. Because these 2 cells are 7, and these 2 cells are 7, and this is a 7, these all sum to 21, right? And 28 minus 21 is 7, so you actually know that these 2 cells up at the top of this cage sum to 7. So we can make eliminations of digits that would keep us from having a sum of 7 in these two cells in particular. And here, this can't be a 6 anymore, because if this was a 6, it would have to be 6 plus 4, which is not 7, it's 10. So that's either 1 or 3. So now what are we going to do? What I'm going to do is I'm going to look at some of the rows and columns that are nearly complete, and I'm going to fill in the outie digits that are not included in the cages. So in this row, my outie digits are 8 and 9. One of those falls on an arrow, actually. So the 8 or 9 falls on an arrow, and like I kind of spoiled right there, it can't be a 9 because you can't put a 9 along an arrow in standard 1 through 9 Sudoku. It just results in too big of a sum. So that's going to be an 8, and I have to sum it with a 1 to make a total of 9. That eliminates 1 here, so this is the 3, 4 option. That's 1 and 6. These two cells are also outie cells. That's going to be an 8, 9 pair. I'll also pencil these in, or actually I won't, because 8 eliminates 8 from those cells. And so I still need a 4 and an 8 here, and there's already a 4 in row 5, so let's place my, that's an 8. I still need a 4 and a 7 here. There's already a 4 in row 5, so I'm going to place a 4 there and place a 7 there. Here, what do I still need? So I still need a 2, a 6, and a 9, and there's already a 2 in column 7. So that's going to be my 2, and then this will be a 6, 9 pair. That makes this a 7 to finish the column, and these are going to be 3, 5, and 6. I have a 3 and 5 in row 2, so that is a 6, and that is a 3, 5 pair. The outies here are 7, 8, and 9 in this column. So I can eliminate 7 in row 1, because there's already a 7 there, and that kind of interestingly gives me this 8, 9 pair. And what jumps out to me here, and again, I'm not totally sure that I strictly have to use this, but it's kind of fun, so I'm going to show it to you, is that in these 3 cells, I can't place a 7, because there's already a 7 in the row. I can't place an 8 or 9, because there's an 8, 9 pair in the row, and I also can't place a 1, 2, or 3, because there are 1, 2, and 3 in the region. So what do I have left? There are only 3 digits left in the range 1 through 9. It's 4, 5, and 6. But the absolute smallest I can possibly make this sum now using only 4, 5, and 6 is 4 plus 5, which is 9. And that makes this a 6. I already have a 4 in this column, so that's a 5, that's a 4. And that resolves a lot of stuff. I still need a 2 and a 1. They'll go there, and I can resolve my 8, 9 pair. Awesome. This is a very nicely constructed puzzle. I'm really enjoying this one. The 8 here makes this a 9, and I still need to place a 7 and 8 in this row. The 2 there makes that a 3, and that is taken care of. I can eliminate 9 here. Perfect. These 2 cells will have to be 4 and 6. These ones will be 7, 8, and 9 to finish the region, but I can't quite resolve those yet. Let's look at this row, because this is looking pretty restricted. I still need a 6, an 8, and a 9. I can't put a 9 there because it is on the kind of stem of an arrow. And if I look at it, I can't put an 8 there either, because 8 would have to be paired with a 1, which would give me a 9. But there's already a 1 in the region. So that's got to be a 6, and then the smallest number I could pair it with would be 3, which gives me the biggest possible total of 9. So that's taken care of. And now I need a 4, 5, 7, and 8 here, so that can't be a 4. Those can't be 8. That also can't be 4 because of the column, so my 4 goes right there. Okay, now I need a 5, 6, 7 here. And I can eliminate 6 from these 2 cells, and the 9 there gives me an 8, 9 pair, which gives me a 7, 8 pair. These digits are 3, 5, 6, and 7 in some combination, no 6. Now, what combination here will give me a sum of 9? Either 3 and 6 or 5 and 4. So I can cut the 7 there. But other than that, I don't quite know what I can do yet. There's a 7 in the column, so I can kill the 7 there. That's now a 7, which that's the only position for 7 in the region. This is now the only position for 6 in the region. That makes this a 5. Cool. Here I still need a 2, 3, 4, and 5. Can't place 2s in those cells because the 2's in the row and column, so my 2 goes there. So now, that can't be a 6, so that's a 4. And this must be my 3. And then that's a 4, 5 pair, and I'm going to work out which way that goes right now because that will be a 4. There's a 3 in the row already. So that's a 5, making this an 8, because 3 plus 5 is 8. Now we can basically finish off the puzzle. Here I need a 1, 7, and 8 to finish the column, and these can't be 1 or 7, so that's an 8. And now that will be a 1. Here I need a 5, a 6, and a 9. The 5 can only go in that position, and that's either a 6 or a 9. And here I'm going to need a 6, a 7, and a 9. The only way to fill these out to make the arrow valid is for that to be 7, that to be 6, and I believe that with some classic Sudoku, that is the end of the puzzle. So that's going to be how you solve Philip Newman's Not Slow Thermo. That was a really lovely puzzle. I really enjoy how we had kind of that spiral of being able to reduce single cells based on the contents of those minimal cages. That really captured that gas vibe of kind of making me feel smarter than I maybe am, or better at puzzles than I maybe actually am in reality. I felt great kind of catching on to that while I was testing this. So really, really nice puzzle. Thank you so much for that, Philip. And I hope that you all enjoyed that. And if you want to try it yourself, a link to solve it in Sudoku Pad is in the description of this video below. Enjoy, have an awesome rest of your day, and I will catch you next time.